I guess everybody's here. Doug, you can go ahead.
Like Jeff said, I'm a recent graduate of Penn College with a couple degrees, one in engineering, electronics engineering technology, 4-year degree, and one in industrial process control, which is a 2-year associate's degree. Right after I graduated, a little bit of background about me, I signed on with a company called A.A.S Automation in Muncie, out by the mall, doing refinery controls, pretty much controlled refiners for the paper and pulp industry, programmed Allen Bradley, PLCs, their control screens, the HMIs. Did that for about a year before things got slow and eventually laid me off. Kind of left me sitting around wondering what I wanted to do next. When Rick approached me with a job in the gas industry, apparently there's a lot of guys coming through the school looking for candidates to work as technicians out in the fracturing industry. So he said it was a position that required a lot of hours. It wasn't all like on your feet work all the time, but it would take up like probably somewhere between 80 and 100 some hours of your week. But there was a lot of money out there for anybody who was interested in working that many hours because it was all pretty much overtime. So I said, yeah, that sounds like it interests me, and eventually applied for the job and ended up out in the industry. It's a very interesting opportunity. It's a lot of fun for someone like, for me, I think it's a lot of fun. It's a lot of outside work. You're moving around from location to location all over northern Pennsylvania. There's the Marcellus Shale, which we work in, it stretches all over this northeastern region. It encompasses all of West Virginia, eastern Ohio, half of Pennsylvania, pretty much the entire Appalachian region, some of New York. So there's a lot of work in this area for fracturing and just for the gas company in general. Where I work now at Universal Well Services here in Williamsport, I am an electronics technician. So my responsibility is to look after the fracturing fleet, make sure our instrumentation is working properly, it's all calibrated. I go around with the rig ups. I follow the fracturing fleet around. I rig up the cables, I hook up all the pressures, the flow rates. Anything pretty much with a wire or a cable is my responsibility, and make sure that our signal integrity is good. Hydraulic fracturing, I'm sure you're not too familiar with. It's a land stimulation technique. When you drill a hole into the ground to extract the natural gas from the shale formation, you're going to get some production from that well, but not enough for it to be economically sound. So fracturing a well pretty much opens up the formation and allows for the gas to flow through. The process of fracturing it's a pressurized fluid system. So you'll have a fracturing pump pumping at high pressure, usually around 8,000 psi, pumping a slurry mixture of water and sand, primarily water and sand, down the well. Yeah, that's right. I have a diagram for you. Here's a pretty good look of what fracturing is. You have your surface, and then you have this well that goes about, on average, 2 miles into the ground. So it's a really deep well, stretches all the way down to, pretend that's your Marcellus Shale formation. Once it gets to the formation, it'll stretch out horizontally another mile, 2 miles, whatever the designed well schematic is going to be, depending on how much gas is in that area. And then that well will be divided into zones or stages, as we call them. Each stage has its own fracture. So what they'll do is they'll send explosives down the well, all the way down to the bottom. We'll pump it in with water to get to where the depth is for that specified zone. They'll perforate the well casing by essentially blowing up these explosives. Perforates the well casing, opens up the shale formation, in essence fractures the formation. And then once you have these perforations opened up, it's pretty much like a hole in the ground. You gotta fill that hole so it doesn't move into the earth and everything doesn't close that hole back up. And we do that with sand because sand has permeability. It allows for fluids to flow through. So we pump a mixture of slurry of water and sand that opens up these formations and keeps them open. And in the process, the more we pump in, the more fractures we can get. It's hydraulic fracture. That's it. So after we fracture, we'll send another charge down the hole, plug off the previous stage, fracture that stage, send more explosives down, and the process goes on throughout. Usually wells are like 15 stages or zones, and a fracturing stage can last about 2 hours. It's a pretty long process. We usually get 3 or 4 stages done a day, and then depending on how many wells are on a location, it could last somewhere between a couple weeks to a month per job. So usually our frackers, our guys are out there for a month at a time per job, and then we'll all go back home when the job's complete, maintenance our equipment, do preventative maintenance, and then in a few days, once we get all 100%, we'll head out to the next location, which could be anywhere in PA. So that's kind of what a cutaway looks like when fracturing. Now I'll show you guys my aerial view of what a job site looks like. Kind of a mess, a little bit hard to see. You're not going to see the wellhead, but the wellheads are typically right in the middle of the well or the pad. Usually at least 2 per job site to make it worthwhile.
The drilling rig is all gone at this point, is that right?
The drilling rig is all gone. The drilling rig is completely separate. That's what drills the hole. That drilling derrick will be there for a few weeks until the hole is drilled and cased. Once it's cased, they pull the bit out of the ground and completely clear out for the land stimulation guys coming, the fracking guys. That wellhead will be connected to all of our iron. Since we pump, our pressures are usually right around between 6,000 to 8,000 psi is what we pressurize our fluid at in order to open up those formations. And that pressure is significantly higher on the surface than it is down beneath the earth. I mean, you're fracking at that many miles beneath the earth, it's going to create some really high pressures. So we hook up our iron to that, since our iron can handle that pressure, and then our iron goes to our pump trucks, which are neatly organized around our well here, usually about 14 pumps. Universal always uses 14 pumps. So our pumps will pressurize that fluid. It's just like any engine. It has it has 1 through 6 gears. So the higher your gear, the higher your throttle, the more pressure you're going to create, the more flow rate you're going to get. Typically, we'll run a job at right around 90 barrels a minute, and it varies depending on that job and how they design it. So in order to get 90 barrels a minute, we need X amount of trucks, usually 14, to get up to that rate. Typically, each truck running in 2nd gear, full throttle, we can get up to 90 barrels a minute. And as your stage will go on, you'll typically lose trucks for packing, for leaks. They'll tell a truck to shut down, and they got to catch that rate on other trucks. So there's a certain amount of redundancy in your pumps. Let's say you can lose maybe 3 pumps before you have to shut the job down because you just can't keep the rate anymore. Now these pumps are all getting their fluid and their slurry from this blender back here. There's 2 blenders on a job site. Again, for redundancy, in case you lose one, you have a backup. You always have to keep a job going, and at the very least be able to flush out a well before you shut down completely. Your blender is where all your fluids mix together, your sand and your water all come into this tub, and it's mixed up just as fast as it's put out, because we're usually putting down per stage about, I think it's 500,000 gallons of water and 250,000 pounds of sand. It's a significant amount of resources to get a stage done. So it's all mixed up in the blenders back there, along with chemicals. They use certain chemicals like a friction reducer to keep the surface pressure down. They use a scale inhibitor to keep the wellhead clean, clean from corrosion, things like that. There's a few chemicals. Universal uses just 2 chemicals, depending on who you're fracking for. They might have a few more, but usually the amount of chemicals you put down a well are less than 0.5% of total water and sand. And then towards the back, you got water storage, sand storage. Your sand trucks will come in and out, refill your sand as you need. They usually pipe water in from a reservoir off-site. Just a few other pieces of
Are those sand
equipment.
trucks enclosed?
Sorry?
Are those sand trucks enclosed or are those big dump trucks?
They're closed. They're bulk trailers. They'll typically blow their sand off with air. It's pressurized and blown into
So
the.
it must be very specialized sand.
Yeah. Usually they'll either use there's several different meshes of sand. They use a finer mesh to start to get into the finer cracks, and then they'll work their way up to higher meshes to get into the bigger cracks. And then there's certain types of like silica sand, there's ceramic sand, all kinds of different sands, just whatever the engineers down in Houston, Texas recommend pretty much. And then, there's a lot of traffic going in and out of the job site. There's constantly vehicles moving, trucks moving. You always have to watch out for yourself. We frack no matter what the weather is, no matter what the temperature is. You can frack in below 0 degrees. You can frack in 100-degree temperature, rain, snow, whatever. The only time we won't frack is if there's lightning. If there's lightning, because you got this big crane here, and that's what supports the explosive to perforate the well casing. They got to put that thing down for 30 minutes after they see a bolt of lightning. Otherwise, we're all in danger. There's only a few things that'll stop a fracturing job, like lightning or fire. Those are big issues. Any questions so far? Yeah, go ahead.
So what you're saying is you're pumping down the sand and water mixture and it's forcing the gas out of the well?
Close. You're really close. Pretty much our objective is just to get sand down there to hold those fractures open. We use water as our vessel. You can use pressurized gas. You can use water. We're a slick water district, so we just use water. There's no gas coming out of the well at this point because there's so much pressure. There's so much pressure pushing it down, nothing can come back up. Once we complete a well and it's completely fractured, at that point they'll flow back the well, get all those impurities out, and for about, I think it's a week straight, they actually burn that well off. I've seen it before, it's really cool. Like they open it up, let the gas fly up, and there's just 20-foot flames.
It's really, really loud.
It's bright too, it's bright at night. So, yeah, there's no gas flow. There's a little bit of gas flow, but not until we actually complete the well and it's ready to go. But let me show you some of the equipment that we use here. Like, this is a little bit of a close-up of a pump truck that we used at Weatherford, one of my previous employers. These are some of the pictures I took while I was on site with my phone, just to give you a good idea of what we're working with. These are all trailer mount, big rigs. Everything we used is transported over the road using like a 10-speed tractor. It's heavy equipment. Some cases they're all oversized loads, like a frac tech. All their equipment is oversized and need permits to get it from point A to point B, which is a real pain, especially on weekends when you have to get a permit to drive this equipment. So there's definitely a lot of limitations that they have. This wasn't oversized. They use huge Detroit diesel engines just to generate these high pressures. I think they're 12-cylinder, turbocharged, 50-liter engines. They're massive. They're marine engines, actually. So that's what generates their pressure. And pretty much what I deal with as a technician is all localized within this control box. Every company has their own method to control. CSP, that pump there, they have their own proprietary circuit boards that it was pretty easy to maintenance these pumps. If something went bad, you usually just replace the one card. It's an MCB board, real simple to program and everything. But I'll show you inside of one of FracTech's pumps in their control box here. You're looking at a lot of automation direct stuff, Healy or DL05. That's going to control all your inputs and outputs on the pumps, like temperatures, pressures, downhole pressure, any kind of shutdown temperature, like your engine overheats, it's going to shut the pump down. This is your brain for the whole pump. And then all your data from that pump is being transferred over radio links, wireless Ethernet card to your main van. Your main van is where all your information is coming in, like your pressures and flow rates, how many chemicals you're putting down the hole. They plot all that stuff on a graph, and then all that stuff's transmitted via satellite down to Houston where they can watch the job live. So all your information is being transmitted back to the van through wireless, at least in FracTech's case. Every other place I've worked for uses cables. in which case would be my job to rig up at the beginning of a job and to tear down at the end of a job. Some of what we do is basically just cable stuff, but a lot of it's troubleshooting too. Like if you were to lose a pressure on your pump, each one of your pumps has a downhole pressure so that they basically can frac up to a certain point, say 10,000 PSI. So you have a set point in your pump that says, I can frac up to 9,500 before I need to shut down. If you don't get a signal from your transducer, your pressure transducer that says, shut me down, it's gonna keep going. So it'll pump beyond that set point and it won't shut down, which could essentially blow up your truck. So it's important to make sure you have good signal integrity, make sure you're reading pressures, all your values you need. And if you're not, you gotta figure out, is my cable bad? Am I communicating with my transducer? Can I read a 4 to 20 signal? Because all our signals out there are 4 to 20 milliamps. As long as if you can use a meter and measure 4 to 20, source 4 to 20, calibrate, it's pretty much what this job entails. So you got all that information being transmitted back. You got some terminal blocks down here, fuses, some relays for work lights, starter. On the front side, you have your displays that tells you what's going on with the pump. Is everything running fine? What's your pressure? What's your RPMs? All that stuff. And then here some push buttons and stuff. But here you got your transmission control module, controls what gear you're in, your throttle, and it's good to know these kinds of things, like how a pump works mechanically, like what gears need to be in, how the transmission works. It uses solenoids to change gears. So say I want second gear, it's going to kick these certain solenoids in to change the gear. If you're not changing gears, you got to figure out why. Well, is my transmission control box working? Or is there a sticky solenoid? It's a lot of troubleshooting. About 50% of what I do out there is troubleshooting problems. A lot of it's long hours. You'll be on site for like 14 hours. I've been on site for up to 20 hours at a time. And a lot of this could kind of just waiting around for something to go wrong, like they'll call you on the radio, say, hey, my pump isn't starting, or it's overpressuring for some reason, go check it out. And so you'll spend a lot of time in these boxes with your head shoved in there. This is an ideal pump. It's very clean. 9 times out of 10 it won't look like this. It'll just be a big wiry mess, a lot of spaghetti wires and stuff. Your PLC will be hanging off and everything. Let me show you the outside of the box real quick here. That's what it looks like to the fracker, the guy who's operating the equipment. He'll go in there, start with your start switch, read, is it braked? What gear is it in? Is it in neutral? That's what your regular guy sees. But then if they leave the box open like that, it could rain. Rainwater is a big problem because their equipment was very sensitive to rain. Like, it wouldn't start. Well, is the screen working? The screen communicates with the PLC. If it's not getting communication, it's not going to start. Things like that. Then you have your manual gauges. It tells you. Just be able to confirm whatever values you're seeing on your pump. I wish I could show you some of our pumps at Universal. We use CSP pumps, so we got this large 10-inch touchscreen display which tells you any kind of pressure or temperature you ever want to see. It tells you engine errors. It tells you what the check engine warnings are. You really have to work close with the manufacturers of the equipment, keep in constant contact with them. Sometimes you have to do updates. You have to upload a firmware update, troubleshoot with them, figure out what the problems are. Here's a blender. That's what mixes up all our slurry. Kind of what it looks like there. I'll show you some more things on the blender here. That's your control screen. Everything on a blender is PID loop controlled, and it's done through these screens right here, our grass detector screens. It's going to control your stand coming into your tub. It's going to control your suction rate going into the tub, your chemicals going into the tub. And if you ever have any kind of problem with your PID loop, something's not working right, you always have your manual control. Because if you can't run sand, if you can't run the chemicals, say your PID loop for your slick, your friction reducer goes out. Well, if you don't have a friction reducer, you're going to overpressure real fast because that's what's keeping your pressure down. If there's a break in it, they need to be able to switch over to manual real quick, keep that chemical going, And then in the meantime, you're up there trying to figure out, okay, why did it die? Am I seeing my feedback? Is my mag pickup working properly? Those guys like to play around with those sensors a lot in order to make their graphs look good. They bill and charge for every chemical, for every amount of sand they use, so they try to make it look as good as possible. So, you know, there's a lot of fiddling around up there. They'll mess with values in the inputs and on the screen. They'll change multipliers to 0. If you have a multiplier reading of 0, it's not going to put any output for that chemical. And they'll do that to prime up their pumps, to prime up their sand. Here you got your engine displays. It'll tell you engine warnings. And you have to have a pretty good idea what you're doing too with the engines. Out at Universal, we use all Cummins engines, and we're equipped with Cummins Insight, which is a program for monitoring what your engine warnings are. You have to be able to troubleshoot engine problems too. So some mechanical experience helps out there, but you'll definitely pick up on mechanical aspects real quick, because that's a lot of what your job is, trying to work together with mechanics, trying to figure out what your problems are. And then for days when you're not fracturing, when you're in the shop, you know, that's when you do your maintenance, make sure your modules are good, make sure you're reading proper values, make sure everything's in the proper range, things like that. Do maintenance on your cables and such. Here's the tub for the blender, where everything gets mixed together. Kind of a mess, a lot of chemicals and sand go in there. You got your sand augers here. The sand goes into the bin and it's elevated through your augers into the tub at a controlled RPM. Say you want 1 pound per sand per gallon. It'll spin at a certain speed to keep that amount of sand going in the tub, and they'll increment the sand rates as the job goes on for the 2 hours that they track for. Tub leveler device, we use Rosemount or Andrus Hauser tub leveler. Tells us what the level is, controls it with the PID loop, same with the chemicals and dry add chemicals. All goes into the tub. And typically, if the tub leveler isn't working, the first thing I always check for is pull that out. And your best chance is it's going to be coated with sand and chemical. That rod, there's a rod that reaches down to the tub and tells you what the level is. Most of the times that'll be covered with like crap, and it'll read 100% all the time. So your tub will it won't fill up because it's trying to compensate for that 100%, so it'll drop. You know, it's real troubleshooting, and a lot of it has to be on the fly real quick, because these guys are hollering at you. They got to keep the job going. They want their equipment fixed right then and there. You kind of got to be fast at what you do.
So can you be up there while it's running, or?
I can. I'm up there all the time when it's running. During a stage, you'll say, I'm not reading my chemical. We need an E-Tech up there. Take a look at it. So I'll run up there with my tools and I'll take a look. And usually it's something stupid, like they forgot to set a setting, or they didn't flip a switch over to auto. But sometimes it's a serious problem. And in rare cases, they'll actually shut a job down to make it work 100% because they want their equipment working properly. Because over the course of 2 hours, anything can go wrong. They can lose, you know, a blender. They can lose several pumps. So they want to start a stage with as much of their equipment as they can. Here's a close-up of our iron. This is the high pressure stuff. The hose is our low pressure slurry. That's what goes into the pump. The pump's over here. They'll pressurize it and spit it out through the 4-inch iron. That's the high pressure stuff into the manifold. This is your low pressure. This is your high pressure down here. And then that goes to the iron up into your wellhead. Wellhead's over here, the risers. There's a picture of the frac man. That's where I work most of the time. I'll be in and out of there, kind of checking up with the treaters, with the company guys, make sure they can read all the pressures. They graph everything from pressure to flow, density, acid rates. Everything gets graphed and plotted and then sent back to Texas and to our headquarters, so that the higher ups can monitor it, make sure the job's running properly. So we have a server in there that stores all of our information. We have battery backups in case our generator dies in our van, power supply, the breakers, a lot of electrical stuff, and then our satellite communication, which transmits everything back. So at any given point, I mean, you could be out in the middle of nowhere, but you can still have internet access because we have that satellite communication, which is convenient for emailing, for looking up schematics, keeping in contact with the guys that you work with, any kind of questions. Kind of stinks though when you don't have cell service out in the middle of nowhere, and you have a question to ask one of your peers. It makes it very difficult. There's another close-up where the blender connects into the manifold. That's a low pressure slurry. There's a typical job layout that I'll see every day, and you know, this is what I see every day. I kind of walk around here, check from pump to pump to pump, make sure they're reading properly, make sure they're running properly, make sure everything's healthy. It's my job to make sure the job runs right, all the electronics are running properly, and if not, to figure out why it's not.
So nobody's clear what's going on at the site, you know, you're walking around, you don't know what's going on?
It's hard. A lot of it's communication. Everything is communication out there. Everyone has a radio. Everyone talks to one another. No one's even allowed close to the iron during a pressure test to make sure that our iron is going to hold during the stage. They'll usually pressure up to 10,000 psi. Make sure nothing leaks. At that point, you know, they'll start fracturing. They'll run acid. No one's allowed near the iron during the acid run. Typically, they have caution tape set up everywhere you're not allowed to go. Or at least at Universal they do. And that kind of gives you a good idea where you should and should not be during that stage. So there's a long list of things you can't do, and a short list of things you can do during your time there. It's hard to pick up at first. It took me several months to get used to what was going on, the process of fracturing. Pretty much what you can and can't do to fix things. Like you can't shut the pump down during the stage. They need that pump to run. Or you can't open this valve to check the pressure because, you know, guides will go off. It takes a while to get used to everything. Here's our frac man at Weatherford, frac pumps. This is wireline. This is the perforation guides. Their explosives are held in this tool trap until the well opens up. Then they drop it down the hole a couple miles and says the depth. What else? You pretty much live at work. This was our E-Tech man at Weatherford. You know, you got your desk, your power supply, soldering iron. You bring your frac bag. It's got your extra pair of coveralls, you know, extra change of clothes in case you get wet in the rain. Typically, at every service company you go, you know, you'll given a van or a truck which is stocked with all your parts. Everything you need. You'll be equipped with a laptop, a cell phone for questions, troubleshooting. You got your schematics, your parts to change out. You'll typically keep track of your own parts when you're there. Anything you replace, you write down, and then between jobs, when you're done with the job, you'll head back to the shop, restock, order more parts. Pretty much you're accountable for yourself out there. If you don't have the parts to replace something that's broken down, you're SOL. I mean, that's your responsibility to fix that truck. If you can't get it fixed, you're in trouble. So you keep all your own parts ready to go. Yeah, I mean, that's pretty much it in a nutshell. I don't know if you guys have any questions. Let's see what other pictures I have here. That's the wellhead there.
How many other E-Techs do you work with?
It's at Universal. I have 3 other peers, 3 other E-Techs.
And are you all on the job at the same time, or maybe 2 of you at the same time, or?
We overlap usually 1 or 2 at a time.
1 or 2,
like
yeah.
it'll typically be 1. The way it works, I work a 7-2, 7-2, 7-3 rotation, so 7 days on, 2 days off, etc. That means 1 guy is usually on days off at a time. There's going to be 1 guy on site, a mid shift to cover between the transition, and a 3rd guy for the late shift. So the first shift's working like noon to midnight, for an example, and then the 2nd guy works midnight to noon, and then you have that guy to cover the shift in between, because usually at night there's not a whole lot going on. There might be doing some perforations, but from that noon transitional period, they're usually in the middle of the stage, so they have that guy to cover in between.
Yeah. And what kind of background do these other E-Techs have? I mean, you obviously come from Penn College.
Right.
What
I come
about
from
the
Penn
other?
College. We have another guy, Daniel Gomez.
Oh, yeah.
Dan works there now.
I kind of wondered if Dan works there. Dan doesn't say a whole lot on Facebook and stuff, so.
No. Yeah, he just signed on there about a little less than 3 months ago. He has the same educational background as me. We have another guy from Penn College, Jared Walsh, who graduated from down there in the ETHS Mall. I forget what degree that is. I think it's like industrial electronic.
Or electrical or something, right?
Yeah.
Yeah.
He has a 2-year degree in that. And then we have 1 other guy who doesn't have a degree. He kind of snuck in the program. He did a lot of quality control stuff. He ran a lot of the graphs, so he had a pretty good grasp on what the PID loops were and how things graphed out and what the electronics portions were. So kind of just having the experience, he was able to get in, but you know, they would like to see somebody out there with a degree, at least a 2-year. It shows that you're able to be taught, that you can learn stuff that's out there, especially a degree in industrial process control. I mean, you're already familiar with a lot of the instrumentation. You work with the level controllers. You work with pressures.
Now, you have to use it like an oscilloscope or at all, or is it just DMM work?
I used an oscilloscope once at Weatherford. They actually had a scope meter, one of those cool little fluke scope meters, pretty compact device. I did use those to measure frequency, like from a mag pickups, to make sure the pickups are reading right. There are encoders on the dryades, the chemical dryades. Make sure your encoder's working right. There's a few times that you have used an oscilloscope, but it's pretty rare that I do.
It's mainly like measuring current, like you said, the DMM.
It's 90% current, 4 to 20 milliamps is all our communications. Our transducers are 4 to 20, flow, everything's 4 to 20 for that matter. It makes it pretty easy. That way, you know, if you're reading negative 3,000 pounds, you know you lost your signal because that's 0 milliamps. It makes it a lot easier to troubleshoot. It makes it a lot quicker too. So if you can work your way around a multimeter pretty quick, source a signal and measure a signal, you're pretty well set to do a lot of the troubleshooting that's out there. Yeah.
Did they tell you how long they're going to be around? I mean, I know they're Pennsylvania,
Long
all over
time.
the place. Yeah, I've
Real
heard 6
long
to 10 years from a lot of the companies, and sometimes more than that.
Yeah, I've heard 15 years. That's probably a pretty general estimate, but for those of you,
That's just for the drilling and tracking part.
exactly, yeah. I mean, after that, the maintenance on the wells, measuring, making sure everything's working properly. I mean, that goes on for a much longer time. And then typically when wells stop producing, sometimes we come back in and refrac a well to make them produce again. So, I mean, the majority of it will be here for at least 10 years, and then it'll slow down a little bit, but it won't necessarily just up and leave. It'll be around for a while.
Probably also other layers of shale down below too.
Absolutely. I mean, the deeper you go, the more there is.
They're going to do a 3D seismograph for this whole area down to 25,000 feet.
Oh, really?
They're getting releases now to do this. That's 5 miles down in a 3D survey, so they can well.
And they can drill that deep.
Yeah, they can do the technology is amazing what they've done, right? Yeah.
Uh-huh.
Did you have a question?
Yeah, go ahead.
So you say you work 7 days on and then 2 days off.
Yep.
When you're out at a well site, do you stay at the well site or do you go back home for that?
I've done a little bit of everything, depending on what company I've worked for. At Fractech, they it was unspoken, but they gave me the option. Like, I was working 110 hours a week, pretty much, which I had the choice. I could either stay on site, get paid to sleep, get more sleep than driving the hour back home and then an hour back, not getting paid for sleep, and then getting 3 hours of sleep at a time. It was a kind of a trade-off. Yeah, I could sleep in my own bed. It's more comfortable for me. Or I could just, you know, go a little bit easier on myself, get a little more sleep. And, you know, they didn't care because they knew the kind of hours you were working, especially at Fractech. I was the only technician for that entire fleet, and they had 2 fleets. So I was between Trout Run and I was between Towanda, PA, kind of jumping back and forth between fleet to fleet, and it really drained my energy. And ultimately, I decided to leave just because they weren't making an effort to hire any other technicians, and I was kind of the only guy to go back and forth, and it really wore on me. But when you're working 7 days on, doesn't mean you're on site for the full 7 days. It means it's kind of like any other job. You work 5 days and you have 2 days off. Like, you work weekdays and then 2 days off. So you go home every night during the weekdays, same as us. We go home every